So previously we saw how to solve log equations. Now we look at how to solve equations of the form a to the power of x equals to b, which is the index form. In indices, we learned that if the bases are the same, okay, the powers will be the same too. So if I have a to the power of x equals to a to the power of n, the power x will be equals to the power n. So for example, solve 4 to the power of x minus 1 equals to 2 to the power of 2. So I'll make them into the same base first. So I have 2 square, which is my 4, x minus 1 equals to 2 square. So since they have the same bases, that means their powers are the same. So 2x minus 1 is equals to 2. Okay, so I expand this out. I have 2x minus 2 equals to 2. Bring my 2 over, I'll get 4, and my x is equals to 2. Okay, but for equations that cannot be expressed to the same basis, apply technique of taking logs on both sides. So just now I can actually express my 4 to 2 square, right? To make the base the same as the one on the right hand side. But now let's look at another question. Solve 4 to the power of x minus 1 equals to 9. I cannot change 4 and 9 to the same base. There's just no way. So what we have to do is we have to take common log on both sides. So common log, a recap, is log base 10. Why we choose common log? Because we can type it in the calculator to get a value. So I'll log both sides. Alright, okay, I have a power here. So using the power law, I bring down the power. I have log 4 equals to log 9. Okay, so don't be afraid of log 4 and log 9. They are values if you key in the calculator. So I'm going to bring in the values to the same side, equals log 9 over log 4. Okay, I'll then have log x equals to log 9 over log 4 plus 1. And when you key in the calculator, I will have 2.58496. So correcting to 3 sig fig, I'll have 2.58. Okay, now I have a question. Solve 2 to the power of x plus 1 equals to 3 to the power of x. So this is an index form equals to an index form, and they have the bases 2 and 3. However, we cannot change them to the same basis, so we have to take common log on both sides. So taking common log on both sides, I will have LG 2 to the power of x plus 1 is equals to LG 3 to the power of x. Using the power law, I will bring down the power. So I have x plus 1 multiplied by LG2 equals to x multiplied by LG3. Okay, don't be afraid of LG2 and LG3. These are values that I can find out from the calculator. So I'm going to put them on the same side. Okay, why is LG2 in the denominator? Because this is x plus 1 multiplied by LG2. So when I bring it over to the right hand side, it becomes divide. So same goes for the x's. Okay, now that I have a value here on the right hand side, I'm going to key in the calculator to find out what is it. So the calculator tells me that it's 1.5849. So x plus 1 over x is equals to 1.5849. Okay, so 1.5849. Bring over the x, so we multiply. Okay, I'll bring all the x's over to one side. Okay, so 1.5849 minus 1 will give me 0.5849 x. Okay, so I'll use the calculator to divide 0.5849. I'll get 1.7096, which is 1.71 corrected to 360.